Hello calculus fans, I'm going to make just a quick overview of section 9.4 and then I'll probably separate a few other topics into smaller videos. I'm making this in fall 2024. We did this experiment in class with different numbers. We did Newton's law of cooling, so I'm not going to go through that. Again, you can watch the recording. We did this example in class. We talked about solving. We took a moment and so it's just this video is just going to be sort of a recap in case you missed any of that. We talked a bit about solving, why you had to divide by the 500 first. All of that we did in class, and you can see in class recordings. We did a problem like this and talked about how it was similar. This gave us a way to think about what this K or R means. We then did our Newton's law of cooling example and tried to predict the temperature at the end of the class. Our numbers were similar to this. So that's all stuff you can see in lecture. I then did kind of a quick, wish I would have done a better job, but a quick discussion of mixing problems. And we did a few examples and I focused on setup. So you can see that. I'm going to make a separate video. I've actually already made it on mixing problems. In that video, I redo the problems we did in class, and then I do a couple additional problems. So that's something to watch. If you were there at class and you understand the first couple examples, you can skip ahead to the part where I do a couple new examples at the end. We did this in class. We talked about setup, the amount of salt coming in. Actually, this example has different numbers than the one in class. So if you want to try this on your own, you can see how things change. You still have to separate. Unfortunately, you have to divide everything over. And then it's the same 4 steps again in terms of cleanup. Sometimes we ask what's the limit as t goes to infinity, but that makes this, because this may go to 0, and the answer is 30. So yes, in my other video, I did a bunch of these already. Okay, so that's what we did in class. The other part of these notes, I go further. So there's more mixing problems. Again, those are in my video on mixing problems, because a lot of students get worried about that. So I made many examples in videos to go with that. Air resistance is a really interesting application. Sometimes there's confusion on just the setup. I think there's one homework question, but they set it up for you. Some of the details about how you label, whether you call the ground 0 or you call the airplane 0, which is what this model does. I remember being confused by that when I was a student. So this model assumes that, but that's really beside the point. Watch my video for a little more information about this. When you plug all this stuff in, you get this model. That because of air resistance, you get this thing called terminal velocity. Super interesting, but in terms of the exams, if I ask you a question, it would have to basically be identical to that. So this is not really that challenging. So in terms of these 4 main applications, we have natural growth, we have Newton's law of cooling, and we have mixing problems are the 3 main ones. Air resistance is on the homework, and we very rarely, once every 8 to 10 years, ask it on an exam. But if it appears, it shouldn't surprise you. So I just wanted to talk. I went through old exams, did this several years ago. When you look at spring 2011 final, we did ask about this. And sometimes students go, I'm confused by all this. But they're telling you this is the force. And so this is the exact problem I just mentioned. And it asked you to solve. That's this problem. That's this. There was a problem I was looking through old exams. Spring 2024 final that talks about a lake that has a certain volume. This is a mixing problem. Instead of a vat, it's a lake. Runoff from the farm, there's 2 cubic meters of water per day that's coming in with 50 grams of pesticide. So there's the concentration coming in. There's the flow coming in. You can watch that video for more. And this is just a mixing problem. Don't be scared by the fact that it says lake instead of vat. The key piece is that P or Y should be divided by the volume. And then you solve, and then it's these same 4 steps of simplifying in algebra. That's it. Winter 2011 final was a money problem. In that problem, it said you earned interest at 10%, and you took out $3,600 a year. So that's a little variation on a theme that I talked about in class. But then once you separate and solve, it's these same 4 steps. So that's why I talked about in class how you don't want to be messing up the algebra there. Yes, there's a few things that happen, but it's the same things over and over and over. Probably one of the harder old final questions was this one. I don't think it's in the exam archive anymore. So you don't really, but I wanted to mention that if you see some crazy name or some function, it's not a crazy, it's a common model, I guess. I mean, I'm not in this area. But it doesn't matter. You're just going to, there's your y. You're going to separate. You're going to then try to integrate this. So challenges of this problem had nothing to do with knowing that model and everything to do with realizing, oh, the derivative of log of y is 1 over I, so this substitution will work. So that's really what they were testing here, was an integration. Then you plug in your initial conditions. Logistics question, that's like the spread of a rumor. This is just me sort of going a little further. I could make a separate video on that, but that's not really something major to know for the test. So now that I've taken you through this, watch my other video to go a little deeper on mixing problems, and then I have another short video on air resistance, and then you should be more than ready for the applications you're going to see.